OPERO Stephen, taking you through a tutorial of principal mathematics. And before we embark on anything, allow us thank God for the great gift of life. Heavenly Father, we thank you for giving us life. We thank you for the wisdom, knowledge, and understanding. God, we ask you to give us the grace, the knowledge, understanding required in this very presentation. Give us the grace to forgive those who trespass against us, and also we ask you to forgive us. All this we pray through Christ the Son, who lives and reigns within the unity of Holy Spirit, one God, forever and ever. Amen. My friends, you're welcome to yet another edition. To all scholars taking principal mathematics as one of the subjects in their combinations, that is Senior 5 and Senior 6. It is another moment for us to share something on a simple topic called trigonometry. Trigonometry is quite wide, that we decided to split it into portions, and I hope by the end of each portion you must majestically match out with something. Otherwise, in this very portion we are looking at other formulae. I told you we have very many formulas in this, and for the case of the formulae, they are not actually limited to other formulae. We have T formulae, we have the factor formulae, the double angle formulae, the half angle formulae, and they are very, very crucial as far as proving identities in trigonometry is concerned, as far as solving trigonometric equations, as far as eliminations of different perimeters in trigonometry is concerned, and so many others. So I want us to embark on each portion and try to give it maximum attention. However, you need to expand your understanding beyond even what we have on this podium. Make much research, visit the school library, read, use all those books you find. I won't specialize on a book, but I know you have books in your schools that are containing this mathematics. So the little you get here, build on it to expand your understanding, your knowledge on trigonometry. And remember, the task is to apply this in the real arena. Part of it, in the real world, the real problem situations that require the knowledge of trigonometry is where we really want to make use of this content. The other formula. So other formula, or the other formula, is used to solve and prove trigonometric equations that are in the form a cos x plus or minus b sine x, or a sine x plus or minus b cos x, where a, b are constants. The expressions a cos x plus or minus b sine x can also be expressed in the form r cos x plus or minus alpha, while the expression of that caliber a sine x plus or minus b cos x can be expressed in the form r sine into x plus or minus alpha, where alpha is an acute angle. Now, if you've been keen and observant, you can vividly prove that we've been trying to solve some trigonometric equations. We've been trying to prove some trigonometric equations that are actually in terms of cos x plus sine x. sine x minus cos x. And at some points we find 4 sine x minus 7 cos x. I'm just giving examples. Where we have sine plus a cos, cos plus a sine, sine minus a cos. Those cases are quite unique. That the best way to simplify them is by making use or making application of the other formulae. And this is how we are expressing them. And in this, we shall realize that if indeed I have a cos x plus b sin x, how can I expand it? Which other formula is suitable for that? So in this tutorial, you will be in position now to choose the right expanded other formula for the task at hand. So it is also used to determine the maximum and the minimum value. I remember telling you some time back that functions, we can determine the maximum, that is under polynomials. We can determine the maximum and minimum value of a function by not only making substitution of it where x is and you substitute, by not only graphing where you graph and where the function, if it is a quadratic function, cuts the axis, x-axis, then at that point, if it is U-shaped, then that is minimum, and if it is N-shaped, is maximum. Not only limited to that. I repeat, not only limited to just differentiating that function, where you have a function and they want you to find the maximum, where you differentiate it and solve for the variable in the task you are differentiating, and then we equate to 0, minimum still equate to 0. They are not only limited to that. Here, as other trigonometric functions are concerned, as far as trigonometric functions are concerned, we get an extra mile of getting also the maximum value of the trigonometric expression and also the minimum value of the trigonometric expression by following some rules of cos and sine. So these values of a trigonometric function, hence the points where these values occur. Well, after getting the maximum or the minimum value of a trigonometric expression, you can still find a point. In other words, you need to find the value of theta if the expression is terms of theta, the value of x at which point at a point where the function attains a maximum value, at which the function, the trigonometric function, attains the minimum value. So in this tutorial, I will use only 2 examples to explain much of it, and the rest of it is in the activities for you to try. So be keen with the examples, then the activities will be more simpler. A learner has to identify the expanded R formula that suits the task, which includes the following. So be careful with the 4. 1. If you have R cos into x minus alpha, expanding it, well, here we are just using compound angle, and that's what we discussed already. So we are expanding. Remember, R is multiplying everything. So we shall have R cos x cos alpha plus R sin x sin alpha. I just decided to use my trigonometric expression in terms of x, and alpha is just an acute angle I'm attaching to it to make a compound angle with the x. R cos into x plus alpha is R cos x cos alpha minus R sin x sin alpha. R sin into x minus alpha is equal to R sin x cos alpha minus R cos x sin alpha. And then lastly, R sin into x plus alpha is equal to R sin x cos alpha plus R cos x sin alpha. This is compound angle for basically cos and sine, plus or minus. Now, we are going to base our choice on these 4 perimeters. However, depending on the task at hand. So when we get into these examples, we find that the task requires us to find the maximum and minimum values of each of the following functions. And the first equation is 5 cos x plus 3 sin x. And the second one is 5 f of theta into f into theta is equal to 1 into 1 over 3 plus sine theta minus 2 cos theta. Now, when you look at these expressions, you get to realize that there is always that part that requires R formula. However, you can still use T formula here. When we get to T formula, we will see what we need to use as far as cos, sine of a double angle, cos of a double angle. Now, since we are talking much of R formula in this very presentation, we need to know how to apply R formula in these equations. Now, the possible questions are: 1, expressing this into R formula; 2, finding the maximum and minimum points or values of these expressions; and then lastly, solving them. Now, the gist of the matter is still starting from expressing them into R formula. Then after that, you take the next step of either finding the maximum value, minimum value, or solving it if the case requires you to solve. And cases that require solving appear in the caliber of the part that requires application of R formula, maybe of that caliber, then they equate it to maybe 1. I'm just giving an example. Even this one here, they tell you this one here, maybe it is equal to something, maybe 2. Then they want you to solve. So this is very, very important, and I will go through the steps of expressing into R formula, finding the maximum. Then I will leave you to try solving it, because after expressing into R formula, you can still now solve, now that you know the range. You can set a range of your choice. I will give you a guide. You can set the 0 degrees less or equal to x for the first one, less or equal to 360 degrees. The second one can decide to put negative 180 degrees less or equal to theta less or equal to positive 180 degrees. Now, I want you to follow how we are expressing it into R formula, finding the maximum. Then I will just give you a hint on how to solve it. Then you'll find the angles, depending on the choice of the limits and also what you're equating to these respective equations. Now, the expected response for the first one, the expected responses for the first one and also the second. Now, I will first borrow the other identities. I need to first have them at my fingertip. I need to first have them. So as I'm trying to express 5 cos x plus 3 sin x in the form of R formula, I first need to look at my expression I'm expressing into R formula before even you decide on the best expression. Here I have cos plus sine. Be careful with that. So I come to my expanded R formula that I gave you at the first. Of course, it must be in terms of x since the thing is in x. Then when I look at cos plus sine, the only one that I have cos plus a sine in terms of x, cos x. So I have cos x, there is a plus, then sine x. Just ignore the cos alpha, sine alpha. But what I really want is to see that I have cos x plus sine x. Here, yes, I have cos x, but this is a minus, so it won't work for me. However much I have sine x. So the order is cos x plus sine x, meaning the first expression will be very, very important, in this part. So that's why I'm saying I let my 5 cos x plus 3 sin x be in the form, or I express it to be in the form of R cos x minus alpha. Because when I expand this, I get something similar to cos x plus sin x. However, it will have some coefficients, but I'm interested in what I have. that must be directly connected to the question. So as you're getting those expressions that require other formulae, make sure you first compare it with the 4 expanded other formulae, depending on the term given. If it is in terms of theta, instead we shall have x replaced by or replaced with theta. So let me go to the gist of the thing now. So I let r cos x minus alpha is equal to 5 cos x plus 3 sin x. I expand it. Already expanded part is there. After expanding, you can see that I have cos x, sin x, and a plus. Even the other side, cos x plus sin x. Now here I'm just going to compare the coefficients. Coefficient is just a neighbor. So the neighbors of cos x and sin x on the left hand side and the right hand side. So when I compare the coefficients of cos x and sin x on the left hand side with those on the right hand side, I get to realize that r cos alpha will be equal to 5. What are we meaning here? You get to realize that the whole of r and cos alpha are the neighbors of cos x, which is r cos alpha. Then on the right hand side, it is only 5 that is a neighbor of cos x. So I'm done with that one. Next, for sine. For sine, I have r sine alpha, which is a neighbor of sine x. Then on the right hand side, I actually have a 3. So that's why I am having something of that caliber. So having two equations, after solving for two things. One, I'm solving for r and for alpha. As a mathematician, you look at these equations and be like, okay, how can I eliminate one parameter, then I remain with the other. When I decide to divide these two equations, equation 2 divided by equation 1, are you aware that r will die and sine divided by cos will be tan? That is what we discussed already. So the left hand side I will remain with tan alpha, and the right hand side will have 3 over 5. When I take the tan inverse of the other 3 over 5, I get 31.0 degrees. At this level, I repeat, we do not look for other angles. That is the very key angle we need. Alpha is an acute angle that we need, and that is it, 31.0 degrees. Don't draw a circle and look where tan is positive. I find you, my brother. Take you back to your village, I'm telling you. So don't do that. Just get the key angle and continue with life. So I'm done with alpha. How can I get r? So I'm deciding to square 1. Then I add it to 2 squared still. Now I went through a short step very fast here, but there's some step I actually eliminated. You see, when you get this equation 1 and you square it, this will be squared, even cos alpha will be squared, even this will be squared. And then also the second one, r will be squared, even alpha, sine alpha will be squared, even 3 will be squared. So I add. When I decide to add this left hand side, I factorize out r squared. I will remain with r squared into cos squared alpha plus sine squared alpha. And that is the identity we know very well in mathematics, that one is equal to 1. Then the other right hand side, I will remain with 5 squared plus 3 squared. And 5 squared plus 3 squared is equal to 25 plus 9. And that will be 34. So that's why I'm remaining with r squared is equal to 34. So when I take the square root, of course, I remain with that, 34. So I choose the positive root. I always have issues with some of my people when we are taking the square roots. Some of them don't want to put negative or positive. Well, here I'm interested in the positive root. So hence, after getting my r and also alpha, what I will do is very simple. I will get back to what I decided to let at first. I decided to let my question to be equal to a specific error formula, that will help me get it is expressed 1. So what I decided to let is error cos into x minus alpha. Error cos into x minus alpha. So this is what I decided to let. And I can see that by the end of the journey, I have already got my r, I have got my alpha. So I just need to substitute them there, and I equate it to the original question. That is 5 cos x plus 3 sin x. That's why I'm saying hence 5 cos x plus 3 sin x is equal to, where r is, I have root 3, positive 1, cos into x minus an acute angle of alpha, which is 31.0 degrees. At this level, this is when we say we have expressed a function at hand into our formula. If the task was just expressing it into our formula, we would majestically end there. However, since the task requires us to find the maximum and the minimum, I will get there. But there is something I want us to negotiate on, such that you will practice it at your free time. Now, if the task required you to just solve, and you get to realize that, okay, the trigonometric equation I have is in form of a cos x plus or minus b sine x, then this is a task that requires our formula. So what I will do is, after expressing it into other formula, I just decide to equate. Now, if the question was solving it, then they are giving you is equal to 1, just like I told you. It means that instead of equating this original question to 1, I will equate instead this to 1, what I've decided to represent it into our formula. So I will equate root 34 cos into x minus 31 is equal to 0. I equate it to 1. So now I start to solve it. Divide through by root 34, divide through by root 34, take cos inverse, get the answer. But here you get all the angles. So you look at the quadrants where cos is positive. If at all, what they are equating to the equation is a positive 1. And if it's a negative, you still consider all the perimeters. And if you missed that presentation on how to solve, please check how do we locate other angles after getting the key angle. So at this level, the key angle you get after taking the cos inverse is the one that will help you to get other angles that are related to key angle, such that their cos inverse, their cos gives 1 over root 34. And here we are actually solving for the x, and you have to respect the range given. So just in case you are required to solve and the expression requires other formula application, then you express it into other formula. Then the output you have is the one you equate to what you have in the right hand side. If it is equated to 1, then equate it to 1. If it is equated to -1, do it that, and follow the protocols of finding the angles. Then, since we want the maximum and minimum, this is very simple. The function, this is equal to root cos of that, attains its maximum value when it is cosine. Let me summarize maximum and minimum. Actually, the next example I will not talk much. I will just get you through it very fast, and I will allow you to do some activities. Scenarios in the item bank. So the function 5 cos x plus 3 sin x is equal to root 34 cos into x minus 31.0 degrees attains its maximum value when the cosine function attains its maximum. Now for this function here to be maximum, this function here to be maximum, which is now represented as this, it means that this part should be maximum. This part should be maximum, and if this part is maximum, then even the function given is maximum. So how is this becoming maximum? That is when the cos is maximum. And for us to have cos maximum, it means that, oh, very simple. Let me give you a curve. Make research on how to curve this. Now, for the cos to be maximum, for example, I've started just plotting my curve, a sinusoidal curve, and I'm using this for sine and cos. So this is 1, this is -1. So this is maximum, and then this is minimum. Still, it's a sinusoidal curve for cos and sine. They are the same. So for cos to be maximum, it means that cos is equal to 1. And if it is minimum, that cos is equal to 1. Then if it is I beg your pardon, if it is maximum, the cos is equal to 1. Then if it is minimum, the cos is equal to -1. The same thing with the sine. So we are going to equate cos into x minus 31.0 degrees, equate it to 1. So where that is, we just put 1. And if it is a minimum, where cos into x minus 31.0 degrees is, we replace that one with a negative. In other words, maximum and minimum is just defining the values within which the function is expected to lie. If you have plotted that graph, you can see that the value, for this case, you can see that the graph is lying within the range of -1 and 1. So in this very particular question, we have 5 cos x plus 3 sin x, which is also called as root 34 cos into x minus 31.0 degrees. It is lying within the range of root 34, I beg your pardon, negative root 34 and positive root 34, because cos of into x minus 31.0 degrees is maximum when it is equal to 1, and it is minimum when it is equal to -1. So that's why we are saying cos into x minus 31.0 degrees has a maximum value of 1 when x minus 31.0 degrees is equal to 0. What are they meaning? This is very simple. We are going to take the cos inverse. The cos inverse of 1. What's the cos inverse of 1? That is 0. So the cos inverse of 1 will help us to equate the x minus 31.0 degrees to that answer. So the cos inverse of 1, 0, then we solve for x as 31.0 degrees. Then the maximum value of that is equal to root 31, and the minimum value of it is negative root 31, as we shall get to see that. Now, since sometimes they require the points, then we shall record the value of x, the value of theta, if it is in terms of theta, to take the first position of the x-axis as a coordinate, and then the value of the function you've got, if it is a positive or a negative, takes the position of y as a coordinate. So that's why the point is 31.0 degrees, comma, root 34. I repeat, cos is positive 1 when it is maximum, for the function to be maximum. And when it's minimum, that cos is a -1. So where cos of everything that is in bracket is, we just substitute 1 for maximum, -1 for minimum. And to solve for x, you equate that to 1, take cos inverse, solve for x. You'll always get one angle that will be written as a coordinate for x and for y as the function, or the maximum value of the function. And I'm not taking it as x all the time. It will never be only x. It can be theta and any other perimeter they are using to represent the angle. in that very trigonometric equation at hand. So similarly, for the minimum value of the function, I told you, the cos must be what? Minimum. So that's why the minimum value is negative root 31. And at that point, we are going to take the cos inverse of negative 1. And the cos inverse of negative 1 is actually, the cos inverse of negative 1 is 180. The cos inverse of negative 1 is 180. Then I solve for x, and guess what? I will have 211.0 degrees, and the minimum point will be 201.0 degrees, comma, negative root 34. So that is it. And before we continue, just in case you have any issue, leave that in the comment section. I will surely respond to it. But basically, that's what we are saying, that we can solve, we can find maximum, we can find minimum, we can find the point, and so on. So we can prove even. Sometimes the task might be requiring you to prove that the function given lies within a given limit, whereby they give you a limit and they tell you, show that the function 5 cos x plus 3 sin x lies within the limits of negative root 34 and positive root 34. That question basically wants you to find the maximum and the minimum value. Then you write them in the limit form, whereby the function is between that limit. However, I am presenting this tutorial well for all students of principal mathematics, and to those under still the old curriculum, this is very important. As well, the new curriculum, this is very important. However, you need to digest the real life application part of it. That's why I will task you to try some of the sample items that you will find in my book as you extend your understanding on trigonometry. You extend your understanding knowledge on the topic trigonometry, on the sub-part, the other formula, and all other parts. So example 2, allow me now go through it very fast. So now what I will do is I will just pick that part that requires other formula, and that is sine theta minus 2 cos theta, and I express it. And I remember telling you I just need to look at what will suit things in this other formula. And the sine theta minus cos theta, I check which one gives me sine theta minus cos theta. I think it is number 3. Yes, number 3. So when I compare that, I expanding it. I compare the coefficients on the left hand side and right hand side. That's coefficient of sine theta and cos theta. I'm getting these two equations. As usual, I simplify the two equations by solving them, solving r and alpha. By dividing equation 2 divided by 1, I get my first angle of alpha, which is the only angle of alpha, as 63.43 degrees. Equation 1 squared plus equation 2. Here we make use of identity. Sine squared theta plus cos squared theta is equal to 1. So as you're squaring that, pull out r squared, you get to realize that what you are remaining with is sine squared theta plus cos squared theta, which is actually 1. So the whole thing on the left hand side will be r squared, and the right hand side will be 1 squared plus 2 squared, which is actually 5. Still, I'm choosing the positive root, and guess what? I have already expressed my part sine theta minus 2 cos theta as our formula. So just in case I borrow this, get it back to the function, I have my original function as 1 over 3 plus 5 root 5. 3 plus root 5 sine into theta minus 63.43 degrees. However, the part that requires other formula is already expressed as root 5 sine into theta minus 63.43. But now the task requires us to find the maximum. The function is 1 over 3 plus sine theta minus 2 cos theta. And this function attains the maximum, attains the minimum value when sine theta minus 2 cos theta, which is also root 5 into sine into root 5 sine into theta minus 63.43 attains its maximum. Allow me to explain that one. A fractional thing that requires you to identify maximum and minimum. Now, if you look at this function here, for the whole of this function to be maximum, it means that, I beg your pardon, for the whole of this function to be minimum, it means that the downer thing, what you are dividing by 1, what you are dividing down, or the denominator, must be maximum. In other words, we want to get a smaller thing. For me to get a smaller thing, I get a very big thing divided by that 1. So that's why, for us to get the final answer as a smaller thing, I need to get a bigger thing divided by a smaller one. So that's why the downer thing, what is the denominator, which is the denominator basically, must be maximum. And that is when we get sign of that being maximum. And guess what? For the denominator to be maximum, meaning sine of into sine theta minus 2 cos theta, which is also 5 root sine into theta minus 63.43, must be maximum. And for it to be maximum, it's only that sine that is maximum. So where that sine into theta minus 63.43 is, we shall substitute it by 1, and that's when it occurs. Then I taking the sine inverse of 1, I get 90 degrees. And then on solving for x, I get something that is 153.1 153.43. So that is how we'll get the theta. In the other case, I had theta as x. Now I have theta as theta. So I told you the angles are not actually limited to only x. No. So now my theta is 153.43 degrees. So I will just substitute where sine theta minus 2 cos theta is. I put root 5 because I said it is maximum when sine into theta minus 63.43 is 1. Then for minimum value of the function finally will be 1 over 3 plus root 5. And then the point, of course, 153.43. I think now it is simpler now. We can just go through it, follow the steps, and just in case you need some help, inbox please. And as a scholar who is eager to learn, these are things that you just need to follow the steps and understand. I don't need to explain much here, please. Just go through them, pick something, and combine. Because what I really want you to do is to try scenarios after you've captured this. I will send you to do some activities, and that's the first activity. Please try that activity. Activities are there. Please try them out.